Hello guys, hi. Welcome to my YouTube channel. So today we are going to learn basic of recursion. Okay, so Russian doll recursive function. Okay, so this is the explanation. This simulate opening Russian doll where one doll contain a smaller doll. Okay, so here Russian doll recursive function. So it is just a basic function. So I am doing start coding. After that we will understand it. Okay, so here I need to define one function like open Russian doll, and in bracket I need to write doll as a parameter, and after that if doll equals to 1 colon print dollar open, all doll are open. Okay, and after that else colon open Russian doll minus 1. Open Russian doll. I am calling function open Russian doll. Okay, so what is the recursion? I have already told you. Recursion is when a function call itself until it reaches a stopping point. Okay, so recursion is a when function call itself. Okay, until it reaches a stopping point. So here you can see it call here this function call here. Okay, so I am going to run select environment. Okay, so all doll are open. Okay, so here if doll equals to 1, print all doll are open, and else open Russian doll minus 1, and open Russian doll equals to 4. So here uh, this is printing all doll are opens. Okay, so this simulate open Russian doll. Okay, where one doll contain a smaller doll. Okay, so doll is the number of the dolls left to open. Base case if doll equals to 1, stop recursion and print a message. Okay, so this is our base case doll equals to 1 here, and stop recursion and print a message. And recursive, this is a base case, and recursive case is open doll minus 1, call the function with the one smaller d, this one. Okay, so after this I need to like a nested function calls. Okay, so here define first first method. Okay, I'm not going to pass anything, and call here second method. Here I am going to print I am the first method. After that I need to define another function df second method. Second method, and here we are going to call third method print I am the second method. After that, I need to define another function. Here I am going to call fourth method. Now I am going to define another method, define fourth method. Now I am going to call first method. Okay, so here this is our output. I am the fourth method. Uh, this will execute first. After that, third method, second method, and first method. Okay, so this is nested function call, not a recursion. Okay, each function call the next one. Okay, so this is a nested function call, not a recursion. Each function call the next one. The print its own message. It's print on message after returning from the call function. Like flow, execution flow. First method call second method. Here you can see first method call second method call third method call fourth method, and fourth method call fourth method call print I am the fourth method. Okay, so control goes back to the third method. Okay, so here you can see fourth method print I am the fourth method, and control goes back to the third method. Print I am the third method, and control goes back to the second method. Here you can see control goes to the second method, and otherwise it goes to the first method. Okay, so here you can see guys, this is for a nested function, or this is for Russell or recursion. Now I need to move simple recursion examples. Okay, so here I mean it is a classic recursive with counting up after recursive method. Okay, so we are going to use recursive method. So here I need to create one function and define recursive method. Here I need to pass n is the number. Okay, and if n is less than 1, print it will print n is less than 1. Else else recursive method n minus 1 print n. Here I am going to call recursive method. Okay, so like this is a classical recursion with the counting up after recursion. Okay, so recursive method. I'm going to take 4 numbers. So n equals to 4. So first goes down to 0, which is called, then print number while returning back. Okay, so here n equals to 4. Here n is less than 4. Then print n is less than 4, less than 1. Okay, so we can compare here n less than 1. Okay, so 4 is less than 1, not, no. So recursive method n minus 1, 1 means 3, and here we are going to print number like 4, uh, first number 4, and after that we are going to I mean they are going to print 3 2 1 like that. And now we are going to move on recursion versus iteration. Okay, so here we can see in recursion. Okay, in recursion version, this is the problem for power. Define POVR, power of 2. We are going to solve problem on power of 2. If n equals to 0, return 1, else power of 2 n minus 1. Here power of 2 n minus 1 and return power into 2. But I need to define power. Power is a variable. So here this is the variable. Power equals to power of 2 n minus 1 and return power into 2. And here I am going to call it like print power of 2. Okay, so power of 2 is 3 equals to 8. Okay, so here we are we already defined function power of 2. Here n is the number, n equals to 3, and if n equals to 0, it return 1, else power of 2 n minus 1. Okay, so return power into 2 into 2 to the power 3. Okay, so here this is our output. Here you can see calculate 2 to the power n using recursion, and base case 2 to the power 0 equals to 1. So this is one base case, and recursive case 2 to the power n equals to 2 to the power n 2 into 2 to the power n minus 1. And in iterative version you can see define power of 2 iterative version and column I equals to 0, n power equals to 1. While I is less than n, while I is less than n, power equals to power into 2, and I equals to I plus 1. Return Okay, so here we can see power of 2, it 16. I mean power of 2 is 4 and output will be 16. Okay, so this is the iterative version. Use a loop instead of recursion. Multiply power by 2 n time. Okay, and output equals to, so the key point recursive is elegant but uses call stack. Iteration is often more memory efficient. It is I mean iteration is use call stack, and iteration is more memory efficient. And now I am going to see factorial function. So I need to define factorial function, and if n in 0 comma 1 return 1, else return n into factorial n minus 1. Here we can see, we can print it. Print fact of 4. So factorial of 4 equals to 24. Factorial is like a if you have numbers like 1, 2, 3, and 4, so you need to multiply all of them, like 1 into 2 equals to 2, and 2 into 3 equals to 6, and 6 into 4 6, 24. Okay, so factorial of 4 is 24. So this is the base case, and 0 factorial of 0 and factorial of 1 equals to 1, and recursive case uh, factorial of n equals to n into n minus 1. Now I am going to doing code for Fibonacci. So this is almost same Fibonacci series. Okay, so I need to change. Okay, so here you can see this is the function for Fibonacci series. If n in 0 and 1, so return 1, else return n minus 1 plus Fibonacci of n minus 2 and print Fibonacci of 4. So this is a 5. So here you can see base case Fibonacci 0 equals to 0 and Fibonacci 1 equals to 1. So recursive case is Fibonacci n equals to Fibonacci n minus 1 plus Fibonacci n minus 2. So output equals to 13. Okay, for this case, not in our case. Okay, so like Fibonacci series is like 0 plus 1 1. Okay, okay, then 1 plus 1 2. Okay, 2 plus, sorry, 1 plus 2 equals to 3, then 2 plus 3 equals to 5, then 3 plus 5 equals to 8, and 5 plus 8 equals to 13. Okay, so this is the Fibonacci number. Okay, so if you need to, if you want to change like numbers different, so Fibonacci of 6 is 13. Okay, if you want to do for 7, now you can see for 7. Okay guys, bye bye, take care. This is recursion. Okay, so I think I have covered some basics of recursion. Okay, so this is for Russian doll. This is for nested function call, and this is a simple recursion example, and this is for recursion versus iterative for power of 2. So this is the iterative recursion version, and this is for iterative version, and this is for factorial, and this is for Fibonacci. Okay guys, bye bye, take care, see you again, love you.